So again, the purpose of this video is discussing two-dimensional vectors. So let's just, again, we've talked about unit vectors, but let's say a little more about that. So a unit vector has a length of unity. In other words, a length of 1. We've already said vectors possess magnitude and direction. Magnitude is basically just a scalar. It's just a number. It's the length of the vector. But sometimes a unit vector is a way of expressing the direction of a vector. And so you can actually take a vector f1, and that's equal to 80 times a unit vector, whereas 80 is the magnitude of f1, and then unit vector is its direction. And so the unit vector can be given, and we're just like as we talked about two-dimensional vectors. So you can have two-dimensional vectors in Cartesian components, in polar, or slope given. And unit vectors can be given in Cartesian form, polar form, or slope given form. And so a unit vector in polar form is, so this F1 vector is 80 pounds at 40 degrees. Well, its unit vector is 1 at 40 degrees. And so if you take 1 at 40 degrees times 80, then you get F as a vector. It's 80 at 40 degrees. If you take this unit vector and say, okay, I want to put him in Cartesian form, then you basically create this triangle that has 1 as its hypotenuse. The x side, or the x component of this guy, is cosine 40, and the y component is sine 40. And so this unit vector is, at 40 degrees, is 0.766 and 0.643 are the components of that unit vector. Times 80 gives me the x and y components of this F1. And so that's a unit vector in Cartesian form. And then finally, if you want to express this unit vector in a slope form, and so we've already given the x and y is 0.6428 in the y, 0.766 in the x. And so if you basically just take 0.6428 divided by 0.766, you basically get 0.839 over 1, which is a rise over a run. Or you can just go the tangent of 40. If you go the tangent of 40, you get 0.839. And so that's a 0.839 rise over a 1. And so you can convert. And again, you can take a unit vector in any form and convert it to any other form. And you need to be able to do that. So a unit vector has a length of 1, and it's a way of conferring or representing or communicating the direction of a vector. And again, one more comment about unit vectors. We already said that our I and J unit vectors are special cases of unit vector. So I is a unit vector that has a length of 1, and it acts in the positive x direction. And J has a length of 1, and it acts in the positive y direction. And K has a length of 1 and acts in the positive z direction. And so a U hat is a unit vector that acts in any general direction, has a length of 1. IJK have a length of 1, but they act specifically in the x, y, or k, or j. I'm sorry, x, y, or z directions. So these are called Cartesian unit vectors. These are called just a generic unit vector. And again, I can take this generic unit vector, and so this is really a 0.766 I term plus a 0.643 3j term. And so for a general unit vector in Cartesian form, it will have some I component and some j component. But again, the length of that guy, the magnitude of that guy will be 1 because he's a unit vector.